Alright, so welcome back to your favorite Inorganic Tutor YouTube channel once again. Today is another episode. We want to look at how we can solve this particular problem on the board. This we are going to use the squeeze theorem or the sandwich theorem. The squeeze theorem is all about three functions that are that the two of the functions are squeezing one in the middle. So imagine this when you are in the middle of this, and this guy is here, this guy is here, and they are squeezing you. It means that whatever weight they possess, this weight and this weight is going to be equal to yours, right? So let's look at how it is, right? So we say that f of x should be less than or equal to g of x should be less than or equal to h of x. So the weight of this guy and this guy is equal to this guy, right? Because we cannot look or we cannot find the weight of this guy in middle here, we find the weight of this guy and that of the weight of this guy. So the weight of this guy is equal to this guy over here, and this guy also is equal to this guy right. So that is all the squeeze theorem all about. So let's look at how we can deal with this particular problem right here. So this right here, we have to set up the squeeze theorem right here. So this right here, we know that sign lies between -1 and +1, right? I'm going to write the function right away because we know what it is, right? So sign lies between -1 and +1. So sign is always bounded below -1 and then above and +1, right? So this right here is what it is. So we have to make sure that the function right here, the function in the middle, possesses the function that we have right here. So what are we going to do? We have to reverse the inequality so that we're going to have divide through by -1. So when we do that, we're going to have 1 right here greater than or equal to negative sine 5x greater than or equal to -1. Haven't changed anything, right? We just divided by -1. So this right here, we can now send this here and send this here, right? Because we always make sure that the lower bound has the minimum value, and that is the negative number, so that the upper bound will have the maximum value, and that is the positive one. So reverse this here and this right here. So we're going to have -1 less than or equal to negative sine 5x less than or equal to +1. We haven't changed anything, we just reverse the inequality, and that is what we have here. So now what we have to do is that we have to add 4s squared to both sides, right? So when we do that, we are going to have minus 4s squared minus 1 less than or equal to 4s squared minus sine 5x less than or equal to 4s squared plus 1, right? So this right here, we can now go ahead and divide through by s squared minus 3, right? So when we have that, we're going to have 4s squared minus 1 less than or equal to 4s squared minus sine 5x less than or equal to 4s squared plus 1. Now this, we can divide through by s squared minus 1 because we have to make sure that the function that is in the middle looks same way as the limit was given, right? So this right here, we divide by s squared minus 3, divide here by s squared minus 3, right here by s squared minus 3. So now we take limit on both sides. We take limit here, we take limit here, we take limit here with respect to as s approaches negative infinity. So right here, we're going to have lim as s approaches negative infinity 4s squared minus 4 minus 1 all over s squared minus 3 less than or equal to lim as s approaches negative infinity 4s squared minus sine 5x all over s squared minus 3 less than or equal to lim as s approaches negative infinity 4s squared plus 1 all over s squared minus 3. So right here, we use our pre-calculus knowledge. We know that this right here, as the value of s increases, this negative 3 becomes negligible because we will not see the importance of 3, this 3 right here, because we know that as s squared increases, because there's a parabola, right? As it increases, this right here becomes negligible. So we assume that we are going to have 4s squared over s squared, and that right there cancels out, and we're going to have 4 right there. So this limit right here is going to be 4 less than or equal to lim as s approaches negative infinity 4s squared minus sine 5x all over s squared minus 3 less than or equal to this right here, also 4. So the limit right here is equal to the limit right here, and that because it is a squeezer, it's like you are squeezing an orange. So when you squeeze this part, you squeeze this part to this, right? So it's like you are pushing the middle one. So the limit right here will be equal to the limit here, and that of the limit here should be equal to the limit here. So therefore, we can conclude that limit as s approaches negative infinity of this function right here 4s squared minus sine 5x all over s squared minus 3 is equal to 4. That is the squeeze theorem. Just have to manipulate, make sure the function in the middle looks same as the function was given. So this right here we have here, because it is the squeeze theorem, this limit over here, if the limit over here is equal to the limit over here, then you can conclude that the limit of the function is equal to this. So this right here is equal to 4. Thank you very much for watching. I really appreciate your time. Please don't forget to press on the notification bell, and I'll give you more updates.